So it's been a while since I last made a video, and for the better, things have actually stabilized in my life, so I can start making them more often again, and that's kind of my hope. In this video, I'm going to be covering up how a portion of how I set up web services, like what I think goes into creating a web service, and then like getting it out there for people to use. So one thing we're not going to be doing is focusing on, design, not focusing on security review, not focusing on things like overall planning. I just want to show you the things that you would do to get things kind of out the door. Like if you wanted to get a prototype of something set up, this would be a great way to do that. And this is obviously going to be done in Golang. I might at some point end up doing these in Rust too, just because I have been picking it up on the side, and it seems to be a pretty promising language. I know a lot of companies are, interestingly enough, they're kind of switching over to using Rust for more critical like services that need to be highly performant. But that'll be for another day. So the specific example that I'm choosing for setting up this web service is a token service, and there's a few reasons for that. I thought it'd be pretty interesting to just do that, because it's not something you'd probably ever have to do or want to do, to be honest. But it is something that I just thought, okay, here's a toy example, we're just going to do that. Now you might be asking, what is a token service? I'm going to call it basically, an entity on the internet that is responsible for creating data used for API authentication authorization. That's kind of a mouthful. So I did look at an example before this, but AWS has a pretty good kind of example. This is the name of the service. It's STS for short, and they have just a handful of APIs to get this job done. And in this case, the tokens are credentials, and I mean that the credentials are used for authentication authorization. And they actually have documentation elsewhere on how they use credentials like this to sign their requests that are made to the AWS APIs. And so you might be thinking, okay, like we have an example here, like what is it actually doing? Well, the idea would be that you use some client to call this API assume role. There's some other setup you'd have to have, like an AWS account, an IAM role, but that's not important. The point is you call this API, you say, hey, I want credentials associated with the read-only role. And what AWS is going to do is it's going to make sure that, one, you have permissions to call assume role. And then once it's done all that, and it knows who you are for the given account, it's going to say, all right, here are the, it's going to do some stuff on the back end, but once it's done, it's going to return you a couple of different strings. And those strings can be used in other requests to, let me look at the response actually. Those strings can be used in other requests to do things like create EC2 instances, provision load balancers, all that kind of like awesome stuff that people want to do when they're developing. And so the other reason that I don't know the full reason that this service exists, if I'm being honest. Like I'm sure at one point every service at Amazon was responsible for its own authentication authorization. My best guess would be that they wanted to consolidate that and make things consistent across the platform, especially and particularly in AWS. So they have this single service, this single entity that's kind of like the source of truth for how do I get credentials. And I'm positive that internally, they're going to be using this service forever. Like this is just the service that everybody has to use, and this API is probably really important too. So now that we've kind of gotten the what and the why, and again, the whole reason that we want to do this is just because it's interesting, and we're going to be doing a super like boiled down version of this. The focus is not so much on what the service does. It's just building the service, getting it deployed, maybe doing CI/CD, setting up telemetry, doing integration testing, all the things that are kind of important for every service on the internet, regardless of what it does. So cool. We're going to be getting right into it then. So I'm going to put this away. So for this, I'm going to make I'm just going to call it token service. Let me go token service. Okay, cool. So I did start playing around with this a little bit earlier, which is why you see something here. But I didn't really get to finishing it when I had the first attempt at this video, but we're going to do it now. So cool, here we have token service. Anytime you set up a a new package or whatever, you're going to want a main.go and a go mod. We're using Go 122, I think, but it doesn't matter. I'm not using a lot of the new stuff. So if you have a more recent version of Go, things should just work like out of the box. Go mod init. I'm just gonna call it token service. Whoops. Oh, that's not what I wanted to call it, but that's fine. Oh, actually wrong place. There we go, token service. Cool. So now we have this mod file. Okay, cool. Yeah, 122 like I thought. So we're using 122. 122 is kind of a big release in terms of like the standard library's approach to doing HTTP routing. I'm not going to be using any of that. Like, I figured, there's so much more code on the internet that isn't using it. In theory, everything that we're doing though could just be completely done with the standard library. I'm not gonna do that. It will literally just be easier and faster for me because I'm just more familiar with other stuff. At some point though, I might make a video on like, okay, this how would you do this with the standard library, but for now it's not important. Cool. So let's check this out. Let's check what they have to say. Let's make sure that we set things up correctly. Oh, go run. There we go. Okay, cool. Hello. So things are working here. Now we're working with an HTTP service. Let's set up the server. So there's a few options for doing that. And if we go to the HTTP kind of package, and we can inspect the source here, which is really nice. Here's the structure. That's not as important as some of the methods on it. Listen and serve. Let's go here. Try and find this. Okay, cool. So HTTP listen and serve has this cool method where you can give it an address and it will just kind of create the server for you. And it's telling you here, oh, it's on a TCP network. So it's not super configurable. It doesn't matter. We're going to be using TCP. This is not going to be a service based on UDP. It's an HTTP service, so it's just going to be TCP. The cool thing about this one is that it'll just kind of use the defaults for you, which is fine. There's nothing wrong with the default configuration when you're kind of testing and setting up, but I think we can do a little better. So we are not going to be using the default servmux, which is what would happen if you use all the defaults. What that would mean is you'd say something like, listen and serve. You'd give it like an address, like it could be 99. It doesn't matter. Oops. So you'd give it kind of like an address, and it would just use the default handlers, and then you just register like, is it this one? I could say like hello, and then put my function right here, and then I could say like fprint. Fprint probably is what we want. Fprint. Is there an ln? Yeah, there is. Cool. Hi there. Oh, and then let me put this. Cool. So there's a super like bare bones. I'm not sure if you need any more setup than this. This might be all you need, to be honest with you. So let me actually just test that. So I'm going to say okay, so there's something's happening here. Let me open up another terminal and curl close. I think this should be fine. Oops. Okay, yeah, so super bare bones server. We're not going to be doing it this way. There's a few reasons. I personally prefer to use the handler interface. So let's pull up what a handler is. Oh, here we go, this guy. So I do prefer to use this interface, like types that meet this interface's definition. this is a fine way of doing things quick and dirty. You probably end up wanting to put your handlers in a separate location, and we'll do that later. But this is the way that I think, it's fine. There's some things that are missing here. Like if this fails, I'd probably want to figure out what the error was if it fails, right? For example, I just send it a signal, like a SIGINT, and I'd want to probably check, okay, hey, did it stop because I don't know, there's just some crash, like something crashed, or was it like somebody actually went and told it to stop? But there's just things that are missing here. This is super bare bones. Let's set up the server. So in the server, for the server, I guess, we want a server, and I kind of pointed this structure before, and it has a couple different fields. Let's give it an address. I'm gonna say 8080 this time. So with this syntax, this will mean that I believe it means that we are listening on all interfaces. So that'd be akin to saying something like this, I believe, but I need to double check that. But it's not super important for what we're trying to do right now. Okay, there's a couple other things. Now, bare bones server, I think this is really all you need. I guess this in a handler. For now, I'm just going to put the default servmux, and this satisfies the handler that we have to put here. Remember, this is the interface, and this default servmux will do that for us. It implements. If you look at the definition of the thing, you'll see that it actually does implement it. Let's see if I can find it. Oh, am I chipping? Hold on. Oh, right, no, right, sorry. This is a type servmux. So, and if I believe servmux should do it. 1 sec. There it is. So the default servmux is just a kind of global variable in the HTTP package. And as you can see here, the underlying type implements the handler interface. So we're good. We don't need really any more than this. This is super basic again. And I think actually, if I'm not mistaken, it's not that different if I said like server dot listen and serve. This is basically the same thing as the other example. So if I go run this again and then I say, oh, not 9090, but 8080. Oh, right. Hold on. Not localhost. Oh, interesting. Let me see. There's got to be. I guess for now I'll just do this. That's fine. Yeah, there's probably some kind of gap in my knowledge there. I thought I had that down, but I guess not. Oh, it's still not found. Oh, duh. So that was fine. The issue is that I don't actually have a handler in here, so we'd have to register it. But we're not gonna. I guess I could do that here. Let me do that here. Handle func, and this will be just the root path, I guess, and then func. Print and hi there, and then yeah, right, W. Okay, cool. So running this again, you'll see that it's effectively the same thing. And I believe I feel strongly that you could do, yeah, okay, cool. So it is listening on all interfaces. Localhost is just one of the interfaces, or it's an alias for one of the interfaces. But yeah, there you go. We're going to take this and basically stand up an actual server. So there's a couple of things that I want to point out here that are important. The server has different timeout configurations that are really critical to set if you're doing anything in production. And the reason you have to do this is because clients just behave differently. They're not all going to be well behaved, and that just means some clients might take longer to do things, and you're just like, okay, I'm not going to spend Go routines on a client that's taking forever to send all of their request headers. It just doesn't make sense, because in that time you could serve maybe 2 or 3 other requests. If somebody takes like 5 seconds to send request headers, you might have been able to serve 3 other requests with the same Go routine. You know what I mean? So you definitely want to configure these timeouts. The defaults are not going to be good enough because they lead to situations where there's just no timeout, right? So the ones that I definitely suggest setting are read timeout and write timeout. The read header timeout, not as critical here. I think that it's going to be the read timeout. So here the definition is saying that it's the duration for reading the entire request, including the body. So clients are sending packets, right, to that make up the requests. I can definitely create a client that just takes a while to send each portion of the full request, each like sort of packet. You definitely want to limit how long the client is allowed to take to do that. It's just you just want things to be stable on your end. You don't want to just let somebody take as long as they want for a given like connection, because the connection is a physical resource on the computer. You know, it's a socket, probably under the hood somewhere. So the other thing is the write timeout. This is basically the time it takes us to do stuff. So this is nothing related to the client. It's like, how long do I want to give myself before I should time out? I don't want to let things take forever, right? If a Go routine is taking forever to do something, you know, that might be an issue that I need to go and solve, but the client connection shouldn't have to like wait, right, that long. So let me go ahead and introduce that. So here we'll say a read timeout, and I'm not going for super crazy here. I'm just gonna say 15 seconds. Actually, I don't even think 15 makes sense. Maybe like 10 seconds. So we're saying 10 seconds here, and then we want to write timeout of 5 times 10 second here. Cool. Actually, no. Let's go about 15. We want to take longer. We don't want them to take this. This should never be the case. This is like extreme cases. Cool. So that's the server, and already this is better than the defaults that you get out of the box, which is great. Next thing we're going to want to do is set up a couple of the sort of extra, I want to be careful, handle things gracefully configuration. So this listen and serve is going to come later. But one thing that I think is important is that you want to, when the program needs to be shut down, or when you're maybe you're shutting it down for maintenance. I don't know what your use case would be, but you'd want to handle all of that gracefully. So a pretty common pattern for that is to use a channel. So something like this. Cool. And here what I'm saying is we have these signals that we can send the program. For example, I'll send it sig int, I think. Yeah, this is an interrupt signal. I just killed the program, and so it stopped. Another way to handle that would be to in code say, okay, I received the signal. I'm going to go and process all the things I need to do to tear things down. And so what you'd want to do that is you'd want to use the signal package and then say, okay, I want to be notify this channel anytime we get a sig int. Yeah, here we go. And there's another one too that people usually do. Oh, it's sig term, I believe. Sig term. Yeah, there it is. Cool. So already we're in a place where we're getting ready to kind of handle things gracefully. So in the background, I'll spin up a Go routine. Again, pretty common pattern here. Equals. Oh, here we go. We want this. Server listen and serve. Error not equal to HTTP server closed. Cool. And then we want probably a fatal. Failed to shut. No, hold on. Not shut down. We're not shutting down. We want to say this failed to start. Failed to run server. And then we also probably want the error. So this should actually be a fatal F. Okay, cool. So far what this is doing is we're spinning up another Go routine for the server to do its thing. And this is not using TLS. We're not doing that. We're actually not going to worry about that for right now, but that's it so far for the server, and I don't think we actually need to touch it again. Like the setup configuration, that's it. And let me explain what's going on here. So listen serve is going to return an error. It's part of the definition of it's part of the function signature, right? You can see it here. This is just syntax saying, it's kind of like a inline, I guess, syntax where I'm getting the error. I don't need it to go anywhere else, so I'm not like setting this up on a separate line. So the scope of this variable is going to be it should be limited to this if statement, really. Then I check what the error is. Now, if the error is the server is closed, that's okay. That's fine. And this is weird, in my opinion. Like, I wish there was a way to say like unless, like it kind of like in Ruby, you can say like unless the condition. But the idea here is if the error is anything but the server closing, then we're just going to say that the thing failed. We're going to log this fatal, and this will actually exit the program as well, for whatever reason. Cool. So let's see. Right now we have to do stuff with the shutdown signal. So shutdown. So let's say we got a signal, because that's kind of what we're waiting for. We can say error equals. Well, I want to say if error equals server dot shutdown, and then we have to give it a context. We don't have one, to be completely honest with you, so I'm just going to say context.background. And again, if the error is not, in this case, if it's not nil, so if there's any error, then we want to pretty much do the same dance. We want to say, okay, failed to, in this case, shut down server, right? And then we want to maybe, I don't know, maybe put a print statement down here. Shutdown complete. Okay, cool. Another thing we could do is, let's see. I think that's it. Yeah, that's pretty much it for setting up a server and gracefully shutting it down. That's it. And to be clear, this shutdown is, I mean, it tells you what it does. It gracefully shuts it down, but this is also an opportunity to do things like close database connections, close any kind of open files, like basically clean up after yourself before the program completely exits. And that's kind of just being a good steward of the computer, because chances are your service is not the only one running on a given like bare metal computer on the underlying one. Cool. So let's see. I think that's really it. So let's spin this up and make sure things look good. I should probably put a print statement saying, hey, the service is running right now. Cool, but let me... Oh, so we don't actually have any handlers yet, so I did that. I'm not gonna curl right now. There's no point. There's no handlers. Everything will be a 404. I guess we could do that. There's a 404. Great. If I go and Control C on my keyboard, on a Mac it'd be like Command key, and I'm actually not sure what it would be on Windows. I don't remember. It's been so long. But it might be Control C. But if I Control C, you'll see this log, and that's because we actually handled the shutdown of the thing. In this case, it was easy. There's no connections. Like there's no traffic. But this just means that we are properly handling the shutting down the service. So I think that's going to be it for this video. I'm just going to decide to break this up into several. It makes more sense that way. Otherwise, it's going to get way too long. But this is what I would do to set up just a basic HTTP server every time. And now you might be thinking, okay, this is pretty repetitive. It 100% is. At the end of this, if you're feeling like, oh, I could make a library to do all this, you totally could. There's nothing like stopping you from doing that. And that's actually something that a lot of people, companies, like projects are doing. They have some library that they say like, okay, set up all of this kind of scaffolding. This is just scaffolding because it's the same every time pretty much. I mean, okay, the port might be different. Here I'm using a default serve mux. Eventually we'll change that. The configuration might be different, but that's kind of it. Cool. So in the next video, what we're going to talk about is configuration. How do you just work with configuration? But the highlights to take away again were the default HTTP kind of like server options are great. They're not what you should use in production. With very little configuration, you can get closer to something that could be put in production. Um, we're not going to be using this default serve mux. I think I'm going to end up using the Chi router, but or like maybe like Gorilla. I don't know. Gorilla is more of like a framework, but I might use the Chi like kind of mux. So I'll introduce that later. And then there's other stuff we're going to do, like, we don't want to hard code stuff like this. We definitely want to just be able to load it from configuration, so we'll do that. But yeah, we're definitely on our way to getting a token service running in production actually. So I'll see you then.